Welcome to the 39th lecture of digital electronics. In this lecture, we will be dealing with the reduction of expressions using K-map. Here, if you are given with a min-time expression or max-time expression, how to reduce that expression into how to reduce the representation of that min-time and max-time into a simplified form of SOP form or POS form. That is dealt in this lecture. Okay, so coming directly to the questions. Coming to the first question. Reduce the following expression. Reduce the following expression. So F is equal to sigma m 0, 2, 3, 4, 5, 6. 0, 2, 3, 4, 5 and 6. Okay. So here you have only up to 6. So you can go with 3 variable K-map. Go with the 3 variable K-map because there is only mapping is already up to 6. So you can go with 3 variable K-map. Okay. So I'm drawing a 3 variable K-map. 1, 2, 3. So here we are having A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0 and 1. So here what I am getting is A bar, A. This is B bar, C bar, B bar, C, B, C, B, C bar. 0, 1, 2, 3. This is 4, 5, 6 and 7. So here you need to fill the terms. Yeah. M0. So you will get 1. M2. This is 1. M3. M4. M5. M6. This is this one. Okay. Now you need to write the simplified form of the expression. If you need to write the simplified form, how you can take? You can take these two forms a quad. Okay. If I am getting a quad, what is the common factor here? C bar is the common factor. So C bar. So first time you got the C bar. Now here we can form a pair. So what is the common factors? A bar is common and B is common. So we get A bar B. And to include this one, here also you can form a pair. So here what you get? A is common, then here which is common? B bar is common. A, B bar is common. So the simplified form of this expression is F is equal to C bar or A, B bar or A bar B. So this is the most simplified form of that is the most simplified representation. Again, if we need to write this in this is in SOP form. Now, if you need to write it in POS form, in product of sums form, the reduced expression, here you are having 0 and 0. That means you will get F is equal to pi m of 1, 7. Okay. But here here you cannot form quads or octet. This is A and this is A bar. And this is B or C, B or C bar, B bar or C bar, B bar or C. So you can write F as, right, in POS form, F as what? A or B or C bar, A or B or C bar, and A bar or B bar or C bar, and A bar or B bar or C bar. Okay. So you can write in any of these two forms. Okay. So this is the minimized SOP form and this is the minimized POS form. Okay. So what is F? Yeah. So coming into now, so I think you have got how to reduce the expression using a K-map. Okay. So f is equal to sigma m 0, 2, 3, 4, 5, 6. You will get SOP expression as c bar or a b bar or a bar b. That is the most reduced form of this SOP form. And POS form you can get it as pi m of 1 comma 7. Okay, that is a or b or c bar, and a bar or b bar or c bar. That is the most reduced form of this expression. Okay, so I think you have got the logic of reducing an expression using this SOP form as well as POS form. Coming into the second question, reduce the expression f is equal to pi m 0, 1, 2, 3, 4, 7 0, 1, 2, 3, 4, 7 and realize it using AOI logic and no logic. So first of all, now see here there is only up to 7, so you can go with 3 variable K-map. Okay. So to simplify, so to draw the 3 variable K-map, having A, B, C, 1, 2, 3. This is 0, 1, A bar, 0, 0, 0, 1, 1, 1 and 1, 0. So here we are having is B or C, B or C bar, B bar or C bar, B bar or C. So 0, 1, 2, 3, 4, 5, 6 and 7. Now if you are writing the corresponding match terms, so this is in the form of match term expressions, right? This is in the form of match term expressions. So if you are representing the corresponding match term, you should designate by 0. So you are having 0 here, 1, 2 and 3, 2, 3 you are having 0, 4 you are having 0, and 7 also you are having 0. So here you are having quad and pairs. So if you are taking quad, what do you get? These 4 forms a quad. So if you are getting a quad, you will get A. Again, these 2 forms a pair. What is it? That gives B or C. These 2 also forms a pair. What is it? That is B bar or C bar. Therefore, the reduced min term expression or reduced POS expression, you can write it as f is equal to A and B or C and B bar or C bar. That is the reduced min term expression. Now if you need to get the reduced that is reduced min term expression. Now if you need to realize it using AND or inward logic, that is using AND gate, AOI logic means you can realize it using AND gate, OR gate and NOT gate only. Okay, so you are having B or C, B bar or C bar. So you are having 3 inputs, A, B, C. So this is B bar. This what you are getting is C bar. Yeah. So first one is you need to take B bar or C bar. This is B bar or C bar. Then B or C. This is B or C. Yeah. Now you need to AND all these things. So this is also B or C. So you can make it an AND gate. So 3 input AND gate, you will get F. Okay. So this is a basic AOI logic. Okay. Now if you need to realize it using this NOR logic, that is a question. So F is equal to realize it using NOR logic, and having F is equal to what? A and B or C, A and B or C, or B bar or C bar. A and B or C and B bar or C bar. So you take F bar. What is F bar? It is A and B or C and B bar or C bar, the whole bar. Okay. What is it? That is A bar or B or C, the whole bar, or B bar or C bar, the whole bar. Okay, according to De Morgan's law. So F bar, that is F, that is given by A bar or B or C, the whole bar, or B bar or C bar, the whole bar. Okay. So this is basically in NOR form representation. Okay. So you are having 3 inputs. A is there, B is there, and C is there. First term is A bar. So keep a NOR gate. So with the two same inputs, you will get A bar. Second term is B or C bar. B or C bar, that is again using a NOR gate. So this is B or C bar. Third one is B bar or C bar. That means here we can take B bar. That means here we can use a NOR gate. This is B bar or C bar or C bar. So that is again a NOR gate. This is C bar. Yeah. Now you will get A bar or A bar or BC bar or B bar or C bar, the whole bar. That means again here we have to get a NOR gate. Yeah. And if you are NORing these three, you can get the final answer. That is a 3 input NOR gate. We are going for 3 input NOR gate. Okay. So here you have realized the expression using only NOR gate. So I think you have got the logic of how to realize the expression using NOR logic only, as well as AOI logic. So here what we have done is we have reduced the given expression using K-map and realized the minimized expression using AOI logic as well as NOR logic. Now coming into third question. Obtain minimal representation of F is equal to sigma m 1, 2, 4, 6, 7. So the given expression is in SOP form or standard SOP form, and again you have up to 7. That means 2 cube minus 1. So you can go for 3 variable K-map. So let me draw a 3 variable K-map. So here having A, B, C. Again that is in min-term form of expression. That is a min-term form of expression. So you can have 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So this is A bar A, B bar C bar, B bar C, B C, B C bar, 0, 1, 2, 3, 4, 5, 6 and 7. At 1 you have 1. At 4, at 2 you have 1. At 4 you have 1. At 6 you have 1. At 7 also you have 1. Okay. So here you can go with the pairing and quadding everything. So these two can be paired. So if that two are paired, you will get BC bar. Again, another pair. You can pair these two. If you are pairing that two, what do you get? This common. A is common and B is common. Here you will get AB. Yeah. Again, one more thing you can pair. You can pair this one and this one. Okay. So if you are pairing that one, what do you get? What is common? A is common and these two which is common, C bar is common. So you will get A C bar. And this is standing out. Okay. This term is actually standing out. So what is it? That is A bar, B bar, C. So this term I can write it as this term becomes what? A bar, B bar, C. Therefore the minimized expression, what I can write it is F is equal to AB or BC bar or AC bar or A bar, B bar, C. So that is a minimized expression. Okay. Now if you are okay, yeah, so that is a minimized form of expression. That is a minimal expression what we can get. And if you are able again, if you are going for this NOR gate or if you are going for the realization using NAND gate, how we can go for the realization using NAND gate? F is equal to F is given by, this is the corresponding minimized SOP form. So F is equal to AB or BC bar or AC bar or A bar, B bar, C. Okay. So what is F bar? F bar you will get AB or BC bar or AC bar or A bar, B bar, C, the whole bar. So what is it? That is AB bar dot BC bar the whole bar dot AC bar the whole bar dot A bar, B bar, C, the whole bar according to De Morgan's law. Therefore you can write F bar bar, F bar bar, that is equal to F, that is equal to AB bar dot BC bar bar dot AC bar bar dot A bar, B bar, C bar, the whole bar. Okay. So this is basically in NAND form of representation. Now we can realize it. So I can rewrite F as F is equal to this is equal to AB bar dot BC bar whole bar BC bar whole bar dot AC bar whole bar AC bar whole bar dot A bar B bar C whole bar taking the whole bar, that is F. So this is the basic NAND form representation. Okay. So you can have A is one input, B is one input and C is one input. So first one is AB bar. So you can have a NAND gate. So this is A B bar. Second one is BC bar. So to get C bar we should have a NAND gate. This is C bar. So this is B. So this is BC bar. BC bar the whole bar. Next one is A is there and C bar is here. So A C bar the whole bar. This is A C bar the whole bar. Then the last one is A bar B bar C. So this is, if you are getting another NAND gate, this is A bar so taking here you will get B bar, then C also you can take here, So this is 3 input NAND. So what we get is A bar, B bar, C, the whole bar. And if you are NANDing these four terms, if you are NANDing these four terms, yeah. So that will get F. Okay. So that is a realization using NAND gates only. Already you know the implementation using AND or invert logic. Okay. So this is how we are getting the minimized expression from a K-map. Okay. So coming into Okay. So with that, we will come to one more problem. Coming into one more problem. Question number 4. Obtain POS form of the following expression. Obtain POS form of the following expression. That is again using this K-map. So question is given by F is equal to S bar or Y is Z bar. So here you are having only 3 variables. So first let me form the K-map directly. From K-map itself we can toggle between these SOP forms and POS forms. 1, 2, 3. This is H, this is Y, Z. 0, 0, 0, 1, 1, 1, 1, 1, 0. This is 0, 1. H bar, X, Y bar is Z bar, Y bar is Z, Y is Z, Y is Z bar. So 0, 1, 2, 3, 4, 5, 6, and 7. So if you are simplifying it, what do you get? H bar, where is H bar? That means this term, that is 1 only, since this is in SOP form. Okay. So the given expression is in which form? That is in SOP form. SOP form means you will get 1. 1, 1, 1, 1. Then Y is Z bar. That means these two terms should be 1. Yeah. So that is now if you are simplifying it, that is the simplified form is given in SOP form, and you are getting 0, 0, 0 here, since nothing is specified. And if you need to convert it into POS form, you should get this is H, this is H bar. So this is Y or Z. This is Y or Z bar. This is Y bar or Z. Then this one is Y bar. Y bar or Z bar. This is Y bar or Z. Okay. Here we can take 2 pairs. So here this is 1 pair. So what is that pair? H bar is common. H bar is common. Then which is common? Y is common. So this is H bar or Y. And another pair. These two forms another pair. Okay. So what I can take from here? H bar is common, or which is common? Z bar is common. Yeah. So therefore the corresponding POS form you can write it as F is equal to H bar or Y and H bar or Z bar. H bar or Y and H bar or Z bar. That is the minimized POS form of a representation. This is the minimized POS form of representation. F is equal to H bar or Y and H bar or Z bar. Okay. So with that I am ending with this lecture. Okay. So in this lecture what we have done is we have done with reduction of expressions using K-map, and also along with the reduction of expressions, what we have done is formation of AND or invert logic, NOR logic, as well as NAND logic. So coming to the first question, in first question we have done with F is equal to sigma M 0, 2, 3, 4, 5, 6. So it is given in min-term form, and we have drawn the K-map and reduced the K-map using quarts and pairs and formulated the corresponding SOP form and POS forms. So in the second one, match-term representation is given, and again we have formed the K-map, and from the K-map we have formed the AOI gate, AOI form of representation, as well as NOR logic. And in the third expression, SOP form is given, or min term form is given. From the min term, we have got the minimized expression, and that minimized expression is realized using NAND gate. And the last one, the question was a tricky one. You are given the SOP expression, so you are asked to find the POS form. So in that case also you can use K-map. That is shown here. So thank you. And in the next lecture we will be dealing with reduction of expression using 4-variable K-map. And in the further lectures we will be dealing with don't KS and how to form. And we are coming to the half of the second module. And after that we will go with adders, subtractors, everything. Okay. So thank you. Hoping you to meet you in the next lecture. Thank you.